NFPA 72 is the national standard for fire alarm and signaling systems. It requires smoke detectors to be installed in certain areas, including areas used for environmental air and enclosed spaces under raised floors. However, there is an exception: smoke detectors are not required in areas where the air handling system is designed to maintain a positive pressure in the space relative to adjacent areas. Now let's discuss smoke detectors in more detail, covering their types, placement, maintenance, and relevant codes. Firstly, understanding smoke detector types is crucial for effective fire safety. Ionization smoke detectors are generally more responsive to flaming fires. These detectors use a small amount of radioactive material to ionize the air between two electrically charged plates. When smoke particles enter the chamber, they disrupt the ionization, reducing the current flow and triggering the alarm. Photoelectric smoke detectors are typically more responsive to smoldering fires. These detectors use a light source and a photosensor. When smoke enters the chamber, it scatters the light, causing some of it to hit the photosensor and trigger the alarm. Dual-sensor smoke detectors combine both ionization and photoelectric sensors, offering a more comprehensive detection capability for both types of fires. These detectors are designed to reduce false alarms while providing early warning of a fire. Secondly, proper placement of smoke detectors is essential for early fire detection. Install smoke detectors on every level of the home, including the basement. Place smoke detectors inside and outside each sleeping area. Install smoke detectors at least 10 feet or 3 meters from cooking appliances to minimize false alarms. Mount smoke detectors on the ceiling or high on the wall, typically within 12 inches or 30 centimeters of the ceiling, following manufacturer instructions. Avoid placing smoke detectors near windows, doors, or air vents, where drafts can interfere with their operation. Thirdly, regular maintenance is critical to ensure smoke detectors function properly. Test smoke detectors monthly by pressing the test button to verify the alarm sound. Replace batteries in smoke detectors at least once a year, or immediately if the low battery warning sounds. Clean smoke detectors regularly by vacuuming or dusting them to remove cobwebs and debris that can impair their sensitivity. Replace smoke detectors every 10 years, as their sensors can degrade over time, reducing their effectiveness. Fourthly, adherence to relevant codes and standards is necessary for fire safety compliance. NFPA 72, the National Fire Alarm and Signaling Code, provides comprehensive guidelines for the installation, inspection, testing, and maintenance of fire alarm systems, including smoke detectors. The International Building Code, or IBC, and the International Residential Code, or IRC, reference NFPA 72 and specify requirements for smoke detector installation in new construction and renovations. Local building codes may have additional requirements for smoke detector placement and maintenance, so it is important to consult with local authorities. Fifthly, let's address interconnected smoke detectors. Interconnected smoke detectors are wired or wirelessly linked together, so when one detector senses smoke, all detectors sound the alarm. This provides early warning throughout the building, especially in large or multi-story structures. Interconnected smoke detectors are highly recommended for residential and commercial buildings to ensure all occupants are alerted to a fire. Wired interconnected smoke detectors require electrical wiring between the detectors, while wireless interconnected smoke detectors use radio frequency signals. Sixthly, let's cover false alarms and prevention. False alarms can be caused by cooking smoke, steam, dust, insects, or malfunctioning detectors. To prevent false alarms, locate smoke detectors away from cooking appliances and bathrooms. Use the hush or silence button on the smoke detector to temporarily silence the alarm when a known cause, such as cooking smoke, is present. Ensure smoke detectors are clean and free from dust and insects. Consider using photoelectric smoke detectors, which are less prone to false alarms from cooking smoke. Replace malfunctioning smoke detectors promptly to avoid nuisance alarms. Seventhly, let's talk about carbon monoxide detectors. Carbon monoxide, or CO, is a colorless, odorless, and deadly gas produced by incomplete combustion of fuels such as natural gas, propane, oil, and wood. CO detectors are designed to detect the presence of carbon monoxide and alert occupants to the danger. Install CO detectors on every level of the home, especially near sleeping areas. Follow manufacturer instructions for placement and maintenance of CO detectors. Replace CO detectors every 5 to 7 years or as recommended by the manufacturer. Eighthly, let's address smoke detector regulations in specific occupancies. In residential occupancies, smoke detectors are typically required in each sleeping room, outside each sleeping area, and on every level of the dwelling unit. In commercial occupancies, smoke detectors may be required in specific areas such as corridors, lobbies, and mechanical rooms depending on the occupancy type and local codes. In educational facilities, smoke detectors are often required in classrooms, dormitories, and other areas as determined by fire risk assessments. In healthcare facilities, smoke detectors are essential for protecting patients and staff, with specific requirements for placement and monitoring. Ninthly, let's discuss system monitoring and reporting. Fire alarm systems, including smoke detectors, can be monitored by a central station or monitoring company. When a smoke detector is activated, the monitoring company receives the signal and can notify the fire department and building occupants. Monitored fire alarm systems provide an added layer of protection, ensuring prompt response in the event of a fire. Regular testing and maintenance of the fire alarm system are essential to ensure its reliability. Tenthly, let's talk about the importance of fire drills and education. Conduct regular fire drills in homes, schools, and workplaces to familiarize occupants with evacuation procedures. Educate occupants about the importance of smoke detectors and fire safety practices. Teach children how to recognize the sound of the smoke alarm and what to do in case of a fire. Develop and practice a fire escape plan designating a meeting place outside the building. Now, continuing on the topic of smoke detectors, let's delve further into advanced concepts and practical applications. Firstly, let's discuss addressable fire alarm systems. Addressable fire alarm systems provide precise location information for each smoke detector and other initiating devices. Each device has a unique address that the control panel can identify, allowing for faster and more accurate response to fire incidents. Addressable systems can also provide detailed information about the status of each device, such as sensitivity levels and maintenance needs. This advanced technology is commonly used in large commercial and industrial facilities. Secondly, let's cover wireless fire alarm systems. Wireless fire alarm systems use radio frequency signals to communicate between smoke detectors, control panels, and other devices. These systems are ideal for buildings where wiring is difficult or impractical, such as historic buildings or those with concrete construction. Wireless systems offer flexibility and ease of installation while still providing reliable fire detection and alarm notification. Thirdly, let's address aspirating smoke detection systems. Aspirating smoke detection, or ASD, systems use a network of pipes to draw air samples from protected areas to a central detection unit. These systems are highly sensitive and can detect even minute amounts of smoke, making them suitable for protecting critical assets in high-value areas. ASD systems are commonly used in data centers, clean rooms, and telecommunication facilities. Fourthly, let's discuss beam smoke detectors. Beam smoke detectors are used to protect large open areas such as warehouses, atriums, and gymnasiums. These detectors consist of a light transmitter and receiver that are mounted on opposite walls or ceilings. When smoke passes between the transmitter and receiver, it interrupts the light beam, triggering the alarm. Beam detectors are a cost-effective solution for protecting large spaces with high ceilings. Fifthly, let's cover duct smoke detectors. Duct smoke detectors are installed in the air ducts of HVAC systems to detect smoke circulating through the building. When smoke is detected, the detector can shut down the HVAC system to prevent the spread of smoke and fire to other areas. Duct smoke detectors are an important component of a comprehensive fire protection strategy. Sixthly, let's address explosion-proof smoke detectors. Explosion-proof smoke detectors are designed for use in hazardous locations where flammable gases or vapors may be present. These detectors are constructed to contain any internal explosion without igniting the surrounding atmosphere. Explosion-proof detectors are commonly used in chemical plants, refineries, and other industrial facilities. Seventhly, let's discuss heat detectors. Heat detectors are activated by a rise in temperature rather than the presence of smoke. These detectors are suitable for areas where smoke detectors may be prone to false alarms, such as kitchens, garages, and attics. There are two main types of heat detectors: fixed temperature detectors, which activate when a specific temperature is reached, and rate of rise detectors, which activate when the temperature rises rapidly. Eighthly, let's cover multi-criteria detectors. Multi-criteria detectors combine multiple sensing technologies, such as smoke, heat, and carbon monoxide detection into a single device. These detectors offer enhanced fire detection capabilities and reduce false alarms. Multi-criteria detectors are becoming increasingly popular for both residential and commercial applications. Ninthly, let's address fire alarm control panels. Fire alarm control panels, or FACPs, are the central control units for fire alarm systems. These panels receive signals from smoke detectors and, at their initiating devices, activate alarms and communicate with monitoring companies and the fire department. FAPs come in various sizes and configurations to suit different types of buildings and fire protection needs. Tenthly, let's discuss emergency voice evacuation systems. Emergency voice evacuation systems provide clear and concise voice messages to guide occupants during a fire or other emergency. These systems can be integrated with fire alarm systems to automatically broadcast pre-recorded messages or provide live announcements. Emergency voice evacuation systems are essential for ensuring safe and orderly evacuation of buildings. Additionally, let's explore some advanced topics related to smoke detectors and fire safety. Firstly, let's delve into the concept of fire modeling. Fire modeling is a computational technique used to simulate the behavior of fire, including smoke movement, temperature distribution, and structural integrity. Fire modeling can help engineers and architects design safer buildings and optimize fire protection systems. These models rely on complex algorithms and data to predict how a fire will spread and affect a structure. Secondly, let's discuss the role of fire suppression systems. Fire suppression systems, such as sprinklers and clean agent systems, are designed to automatically extinguish or control a fire. These systems are often used in conjunction with smoke detectors to provide comprehensive fire protection. Sprinkler systems release water to suppress the fire, while clean agent systems use inert gases or chemical agents to extinguish the fire without causing damage to equipment or materials. Thirdly, let's address the importance of fire-resistant materials. Fire-resistant materials are used in building construction to slow the spread of fire and provide occupants with more time to escape. These materials include fire-rated drywall, concrete, and steel. The use of fire-resistant materials is an important aspect of fire safety design. Fourthly, let's cover the topic of smoke control systems. Smoke control systems are designed to manage the movement of smoke during a fire, preventing it from spreading to other areas of the building. These systems use fans and dampers to create pressure differentials that direct smoke away from exit routes and protected areas. Smoke control systems are commonly used in high-rise buildings and large commercial facilities. Fifthly, let's discuss the use of thermal imaging cameras. Thermal imaging cameras can detect heat signatures, allowing firefighters to locate people trapped in smoke-filled environments. These cameras are also used to identify hotspots that may indicate a potential fire. Thermal imaging cameras are an invaluable tool for fire suppression and rescue operations. Sixthly, let's address the challenges of fire safety in historic buildings. Historic buildings often present unique challenges for fire safety due to their age, construction materials, and architectural features. Preserving the historical integrity of these buildings while ensuring adequate fire protection requires careful planning and innovative solutions. Fire suppression systems may need to be concealed or modified to minimize their impact on the building's appearance. Seventhly, let's cover the topic of wildland-urban interface fire safety. The wildland-urban interface, or WUI, is the area where homes and other structures are built near or among forests, grasslands, and other natural areas. These areas are at high risk of wildfires, which can quickly spread from vegetation to buildings. Fire safety measures in the WI include creating defensible space around buildings, using fire-resistant building materials, and implementing community fire prevention programs. Eighthly, let's discuss the importance of community fire safety education. Community fire safety education programs play a vital role in preventing fires and reducing fire-related injuries and deaths. These programs teach people about fire hazards, smoke detector maintenance, fire escape planning, and other important fire safety topics. Community fire safety education is essential for creating a fire-safe environment for everyone. Ninthly, let's address the role of technology in fire safety. Technology is playing an increasingly important role in fire safety with advancements in smoke detection, fire suppression, and emergency communication. Smart home systems can integrate smoke detectors with other safety devices and alert homeowners to potential fire hazards. Drones can be used to assess fire damage and monitor fire spread. Technology is helping to make fire safety more effective and efficient. Tenthly, let's cover the topic of fire investigation. Fire investigation is the process of determining the origin and cause of a fire. Fire investigators use a variety of techniques, including physical evidence analysis, witness interviews, and fire modeling, to reconstruct the events leading up to the fire. Fire investigation is essential for identifying fire hazards, preventing future fires, and prosecuting arsonists. Remember, staying informed and proactive about fire safety is crucial for protecting lives and property. While understanding the principles of fire detection, suppression, and prevention, and by adhering to relevant codes and standards, individuals and communities can create a safer environment for all.